Hello students, welcome to the thermodynamics subject. So here we are going to discuss about model number 2, that is the chapter work and heat. So in that we will discuss about mechanics, definition of works and its limitations, and thermodynamic definition of work, examples and sign conventions. Okay, so generally you are in the lower level class you have studied about the work. Okay, what do you mean by work? You know that. So whenever you apply force on an object, so in the direction of force itself, the object can move. When it is hits the object or put a force on the object, so it will be move in the direction of force itself. So that is what we called as work. So we can mathematically expressed as W is equal to F into dx. So where dx is a very small displacement, okay, the change of position, okay, the cause of change of position itself, it is a work, okay, cause of change of position itself also we call it as work. So here we are applying a force, so in the direction of force itself the object can move, okay. So if it is this is the definition of in case of mechanics. So what about in case of thermodynamics meaning of work? Okay, let us see. So thermodynamics of work is the work is the energy transfer across a system boundary in an organized manner in such a way that soul used could reduce to lift a weight against the gravitational effects. Means, so whenever the work is going to be transferred across the system boundary, so it should be a systematic way of the reducing the reduce to lift the weight against the gravitational force. So so it has to be change its sole effects of the position. So when it's lift the weight means it is changing the position. So that is also a work. So according to a thermodynamics, let us discuss one of the example. We'll discuss. Okay, consider battery and motor arranged system. So the motor is run driving a fan. Okay, this is one concept. So as fan rotates, the system that is battery and motor is doing upon surroundings, correct. So when fan is replaced by pulley and weight, the weight may be raised with a pulley, so which is driven by the motor, okay. Thus the energy from the system gets transferred to the surrounding in an organized manner, and it is also utilized the lift the weight against the gravitational effects, okay. This energy we call it as work, okay, that is thermodynamic work, okay. So let us discuss with a proper diagram. So I'll explain. See here in the diagram, it consists of battery, switch, motor, pulley and weight, okay. Battery and motor we consider as one system, and the outside the battery we call it as surrounding. So when you replace, okay, instead of fan you replace by the battery, what will happen? Sorry, pulley. So the pulley can lift the weight. When the battery is connected to the motor, motor shaft is connected to the pulley, so pulley can lift the weight against the gravitational force. This is the definition of work, okay. Next, sign convention for the work. So in the mathematical expressions for the heat, whether it is positive heat or negative heat, we are going to mention in a sign convention whether positive or negative. For example, work is done by the system, means any of the system is performing work and produce some amount of work, we call it as positive work. For the same case, if the system is taking energy from the outside, means surrounding to a system, means we call it as negative work. I will give a good example for the positive work. Example, the turbine. The steam turbine, when the pressure of the gas or steam is passed over turbine, so simply that turbine will be rotating. It rotates and produces some work. So it is cannot consume any energy. Okay, that is producing power or work. So there are two types of devices in mechanic. Devices are two types. One is power developing devices and power consuming devices. So turbine is one of the power developing device, and it is hence it is a positive work, means it is producing some work. For the other case, for the negative work, so how we are going to consider, for example, compressor. If you take, the compressor cannot be run by itself. The compressor, it has to work based on the investment of some input energy, means you have to supply some form of energy, electrical energy, then only the motor will rotate. Otherwise motor is dependent on electric power. So it has to consume some energy, then hence it will be called as negative work. So the work is done by the system to the surrounding, we call it as positive work. Work is done on the system from the surrounding, that we will call it as negative work. Okay. Next, we'll discuss about the what is meant by PDV work or displacement work. So first of all, for betterment understand purpose, I'll explain what is meant by infinitesimally small of work done. Infinitesimally means it is very small, very closer to zero. After the zero, nothing. So that value we call as infinitesimally small. Okay. So that work, how you are going to consider for the whole system. Suppose if you want to calculate very small amount of work in a system, so how you are going to calculate? So example, force into displacement, you know that. So general definition of work, that is force into displacement. So what is the force? Force is nothing but pressure into area of the piston. If you consider displacement for piston cylinder alignment, okay, piston cylinder alignment. So what happened? The gas which is expanded through the piston, so it will be move upwards. So that is P into area of the piston. And what is the distance traveled by the piston from beginning BDC to TDC or TDC to BDC? That two dead centers are there, no? So how much volume is covered? So that is what we call it as dV. Okay, displacement. Okay, so pressure, area of the piston, and what is the distance traveled, that is dx. Very small amount of displacement is taking place. So hence we call it as infinitesimally small distance, infinitesimally small amount of distance covered, that is dx. Now once if you know the dx, so what will be the equation? Pressure, area, and dx. Dx is a distance, so area into distance is nothing but volume. Okay, so that is a into dx. So we call it as dv, because area is fixed, we can't change the piston area, but the distance traveled by the piston, that we call it as dx, that is the variable, hence we call it as a into dx is nothing but dv. Okay, so p into dv, that is the displacement work. So I hope you understand this. Suppose if the piston moves through the finite distance, so the maximum distance, the overall distance if it covers, so what we have to do? We have to integrate of that equation. So integrate about the above equation, what happened? Integration of 1 to 2, that is from 1 to 2, then integration of 1 to 2 into dv, where 1 to 2 are the initial and final states. So hence we call it as, this is the displacement work. So we can't write it, we can't integrate the w, so or else either we have to write w1 to 2, or simply we have to write delta w1 to 2. So this is because further we'll discuss about why we have to integrate for this w, and why we cannot integrate for the w or other point functions. We'll discuss. So right now you understood what is meant by PDV work, that is integration of 1 to 2 p into dv is equal to w1 to 2. Okay, next, very important concept is point functions. What is meant by point functions? point function is nothing but where we can find out at any instant the variables of the properties, like example pressure, volume, temperature, entropy. These are all we called as point functions, because at any instant on PV diagram we can find out the correct value of the property. Okay, example, if the distance traveled by some distance, the the fluid or the gas in a piston, it is covered at some distance, what we call it the dx. So we can find out what will the distance covered from 1 to 2, that is x, that is dx. So if you integrate it, we can find out x2 minus x1. But where path functions we cannot define, because path functions are indefinite states like work and energy. So work, after the completion of work only we can say how much work is done. At the beginning state we cannot say how much work is done. Correct? So similarly the heat, after the heat transfer from surrounding to system only we can say what is the heat transfer, what is the work transfer. So that's why the heat and work are path functions, whereas all other property of a system we call it as point function. This is very important and very fundamental concept to understand all the concept related to the thermodynamics. Okay, so let us will discuss in the next video. Thank you.